Hello and welcome, everyone. Thank you very much for tuning in. My name is Heinrich, and I have the great pleasure today to sit with Benedikt Stemmildt here. Welcome, Benedikt.
Hi, welcome.
So, Benedikt, you are the most knowledgeable person and prolific person about agentic software engineering. So, and I actually dragged you in front of a screen and in meetings for the third time today, because throughout the interactions, I was always like, wow, okay, I'm learning something here. Let's show this around. And we have the last iteration done in a Zalando internal mini podcast, which was widely successful. And we are trying to replicate and maybe make it even better. This
It's going to be better.
conversation here, yeah,
Yeah, yeah.
today. It's the day. Also, it's
Yeah.
like 2 months older, so it's
Yeah,
there's
it's
so
all
much
new
happens.
now. It's all
Yeah.
new. Yeah.
But just to say a few more things about you, you are ex-Blume engineer, ex-Bräuninger, ex-Otto, and leading software engineering roles. You were CTO at Teleformation. This is also the setting in which you were doing agentic software engineering with a consulting team on sites with various customers, really writing production code and trying a lot of these things out. And you are a freshly minted founder at CTO at Hackers and Wizards. Congratulations to that.
Thank you. Yeah.
Do you want to tell us maybe a little bit about Hackers and Wizards or about your history? Is there something I missed?
Yeah, I can. Thank you so much. As you said, I'm a freshly baked founder. It's a super new experience for me. I knew that I always wanted to do that, but it was I was actually always a little too scared, I'd say, and now it kind of everything came together at the right moment. Um, I always like to introduce myself in a way that I tell my story. As a kid, I was like, I had the opportunity to, in an early age, get a computer already. So my father bought a computer for us when I was 9 years old. It was already a Pentium 4, so I'm always a little bit sad because I didn't quite do the C64 stuff and so on. But yeah, I had the chance to, at this very early age, kind of, experience my passion for technology, and that grew over the years. And in the end, now it kind of made me realize that that I want to kind of show the world that there's a lot of creativity and a lot of passion and a lot of energy and magic in software engineering, and this came all together to this brand name of Hackers and Wizards. There's actually another story behind that, but we probably don't have the time for that. So I'm super happy to be here today. Thank you so much.
I'm just curious what the market or the rough product is going to be. The name is just very it could be anything, right?
Yeah, it could be anything. Yeah, the product is not really a product. So I'm kind of in the consulting business still, or in the training business. So I'm just helping developers, CTOs, head of engineering to make use of all of these AI tools, make sense of them, figure out what works, what doesn't work, and actually also how to scale that from being used by individuals into a more process and team collaborative way along the whole software development lifecycle. And that's kind of what I do. And I have trainings there, and I also have a community that's going to be announced in a few weeks, where people can register online and get access to me and to others of my network to discuss these things and to have access to resources and so on. I think I hope it's going to be a success. Communities are always a little different, right? Or difficult. Either they die immediately or they pick up very, very quickly. Yeah.
Yeah, for sure. It's not the most straightforward business model, but
No.
I see that we are 100% on target with our conversation today, since you are kind of focusing on this aspect.
Yeah.
Maybe just for our listeners, this is not a typical podcast episode, because we really want to show you directly how agentic software engineering currently works. So we have that produced with video. So we invite you to kind of go to YouTube or to Spotify and switch on the video. So you will be able to see on the screen what Benedikt is doing. And we will try to kind of explain a little bit what's on the screen, but we will see how successful that is.
Yeah.
Then once we have made the demo, maybe we will take like 20 minutes for that. We will kind of abstractly talk about what we saw and how this kind of has implications for how we write software in teams, companies, and so on. But yeah, for the first part, it will be actually kind of a demo. And maybe also to say this, I think it's fair to say this is an opinionated demo. I think there are a lot of different ways to do the same thing.
Yeah.
You can do basically with all the foundation models and a lot of different kind of tools, you can do similar things, but we are deliberately just picky. We just do it one way, which we kind of know that works.
Yeah, exactly.
So yeah, let's maybe set the scene here a little bit before I give you a proper on-ramp. So basically what we are trying to do, or the problem that we are having is like, we are in the age of LLMs, we are in the age of like vibe coding and so on. We're seeing so many prototypes being built, but a real quest and challenge for a lot of teams, companies, and developers is how to build proper code. So how can I kind of work with legacy code bases? How can I work with just my applications that I work on? And how can I make this is a proper engineering task and not just a hack that I can bring into the scene? And that is, of course, if you solve that in any meaningful way, you are opening the door for actual productivity increases and not just like short-term wins, which you are paying by increasing maintenance burden or increasing deployment risks and stuff like that. So that is kind of the high-level problem. And Benedikt, you have been doing this over the past like month and maybe even years, probably not that many years, in production with different companies. So maybe we want to kind of start a little bit about the history and how it evolved and what kind of the core insights are, and then we kind of jump into the demo and the setting and just look at how it works.
Yeah, sure. So I think you are completely right when you say that this is going to be an engineering discipline. Or not going to be, but this still is an engineering discipline. The first time I came into contact with it was when this Aider tool was released around. I think it's nearly 2 years ago, and it wasn't even an agentic tool for developing code. It was more like a workflow-based LLM tool to kind of guide you and help you developing your code. And it was back in the day when the foundation models were also still not very good. I mean, from the perspective of today, they didn't even have tool use and so on, right? And I was not that hooked back then. I thought, okay, well, it's not like quite working very well. But I got curious and followed it. And around a year ago, I think, or in the beginning of this year, there was this inflation point where suddenly it all worked, right? So the model got better, also in using tools. The ideas around what is an agent and how to actually develop an agent got to a point where it was kind of able to also invoke CLI commands locally and so on. And suddenly we had this huge boost in possibility. That was when I realized, okay, we can actually like let this stuff build software. And to kind of, why is it an engineering discipline now? Because at the same time, people introduced Bolt.new, for example, or Lovable products where you could just give a prompt and they will build a whole application, and that opened a market for people that felt that they can build the world now. They don't need engineering anymore. It's not important. We don't need engineers and so on. But in the end, this all works for a few iterations, right? You can prompt like 10, maybe 20 times, but then this all gets super slow, super buggy. There's a lot of security issues there. And I feel that this is because the people that are doing that or using that in this way, they forget about all the engineering principles and all the practices that we've learned over the last decades, and not only like in engineering directly, but also stuff like Scrum and Agile and so on. And they kind of throw all of that away and say, okay, we just need to prompt now. And for me, that is not working. So I kind of try to figure out how to actually do that based on all of their principles, and kind of create a way, an interactive way, and using all of this knowledge, the past knowledge, and create software that is of the same and great quality that we as engineers produce. Yeah, that was kind of the story behind it.
Yeah, that makes a lot of sense, and it resonates very, very much with the kind of general insight that works for humans, mainly also works for LLMs. It's like there's like surprisingly many things that carry over one to one, and so we want to evolve from kind of the model where we are kind of hacking software together in one-shot efforts, and then deploying it and seeing how it works. I mean, it will work for a certain amount of time, but also the people that I talk to, which are non-engineers, they are running into real walls after there's a certain amount of complexity that accumulated. So yeah, I think that is where this kind of engineering discipline sits, and where we as software engineers, at least for the next few years, I think will spend our time with in that kind of position, enabling and accelerating software delivery. Yeah. All right. Should we just go right into it? Maybe just talk about the demo project, where it comes from, and how this kind of whole thing works.
Yeah, sure. Okay, so let me give you the demo and the introduction. As you can probably, some of you can already see, I have my IDE open here in the background. The usual setup now is to have the terminal on the right side, because you will use it for interaction with Claude or with any other tool. And yeah, as I mentioned it already, I'm using Claude here. I really think that they did a great job on this agent system that they built, or this agent, however you want to frame Claude Code itself. Because they really built a general purpose agent for all kinds of tasks. Kind of sadly, it's called Claude Code to suggest it's for coding. But in the end, I feel that you can use it for a ton of things. And the best thing about it is that you can configure it very, very intensely, and kind of frame it to the specific use case that you have, and this is called context engineering for some, and configuring the rules and the workflows and so on that this agent will do, and the MCPs that it has available, and all these things that is something that we want to look into now in this demo. And I kind of want to show you one way that I configured it for this particular project. And my idea is to kind of give you an overview of what is actually achievable and what you can actually do with it from a perspective of configuring the whole environment. So it's not really about the project itself. It's more about the configuration of Claude Code. And in the end, I think that you would kind of figure out how to configure it for your specific use case and for your specific environment. So I think you already mentioned that it's highly opinionated on this specific use case. Okay.
Yeah. So we are basically seeing like VS Code, relatively standard setup with the terminal and Claude Code open on the side. From the technical perspective, from the kind of process and team perspective, so that would be, we are kind of checking out our applications. We have been are either onboarded already to a team and are looking to make some changes to an application, right?
Yeah, exactly. So I thought it would be a good idea to bring a legacy application. So this is a very old application. It's around 6 years old, and I haven't touched it since the 6 years. Only now to prepare the demo or the setup of Claude Code, but the code has not been touched. And the idea here is, as you said, I'm simulating to be a new developer. I've never seen this system at all. The team that I'm working with, or the team that I'm joining, has this Claude Code setup as well. And what they already did here is they already prepared a user story for me to work on. but I don't know it yet. They said, well, here, this is your environment, and we already did our planning and our refinement, and we also did it with AI, so we can talk about it later maybe a little bit, how to expand it out of only generating code. But in this case, I, as a new engineer, would probably just ask the Claude Code, what is this project about? Because I don't have any idea. And this is kind of the easiest. I mean, you have seen that all over the internet, that you can just ask it what this project is about, and it will give you a great answer. So this answering machine is quite of a nice use case. We will go deeper in a second. Yeah, so it gives you an answer. And I can actually see now, okay, it's a project from my Blume 2000 days. It's a service to find products, and it has a Quarkus backend written in Kotlin and a front end in Vue.js. So we have like a self-contained system here, which is quite a nice setup as well for an AI to develop on. And yeah, that is our setup now. That we want to implement a user story.
Okay, wonderful. So, I mean, there may be some padding how we arrive at this exact situation, but it's a very common situation. You have kind of a rough understanding what you are doing, you have a rough understanding of the business and the context, and now it's kind of your workday starts and you want to get kind of going with a ticket that a feature that you want to implement, right?
Yeah, so I asked it as well, like, what is the next topic I should work on? And it now will figure out based on this setup, and I will explain it a little bit in detail later as well. It will kind of figure out what the next issue is that I should work on. I mean, as an engineer, I don't know, are they using Jira? Are they using Asana or any other tool? I don't really know. But the agent system knows. And I can see now here as a result that it says, well, you want to implement a new story, and the goal is to kind of introduce a new attribute to one of the entities that we have here in our code. Let me open that for you so that you can also see. So we have a product here that you can search for, and we want to add a new attribute here to the product with which is a description, a Beschreibung. The code is even in German for some parts, so we will also see that it can work with German code. And this Beschreibung should also be persisted into our database and be able to be queried from the API. So you can actually like have a regex matching with the query parameter to kind of filter out all the products with a certain containing a certain Beschreibung. Yeah, that is the story that we are going to work on.
Okay, cool. Just to make sure I have that correct, this is a search service or a product registry. Like, how would you describe the application?
Yeah, it's a search service. So what happens here is, you have this API to search for the products. They are in a Mongo database, and they are also being stored by reading the data from a product management system via a Kafka stream and saving it to the database. But it's mainly a search here. Yeah.
Okay, cool. We have some asynchronous ingestion going on, and then we have a fast lookup. We have a Mongo who stores the state, and we are kind of in this intermediate layer. And we want to expose an additional field. So I need another field in the database or in the model. Need to change the APIs, change the data structures. That makes sense. Okay, cool.
Yeah, and what we can actually see when we look a little bit closer into the files of the project, and we will do that probably in a minute as well, but I also want to kick off the agent in a bit. But we can see that we actually have this story also in here as a markdown file, because it pulled it from Jira or from any of the task management systems and saved it in a meaningful way. But what you can see and what I actually wanted to show before kicking off is that this is like actually more than a typical user story, because typical user stories I see in teams, they are mostly very short, because in the refinement meetings and in the planning meetings, the team is discussing about the stories, and then they don't need to write all of it down. They have it in their head, right? Because they discussed about it. But for the agents, we need to give it a little bit more of textual information, and how to do that and how to incorporate that in the development process is maybe something that we can discuss in a few minutes as well. But yeah, this is like the basis of this project, is to have like a little bit more of context than just the name of the story or something, right?
Yeah, that makes sense. We are seeing it like a 2-page Markdown file that kind of describes the feature request with a little bit more details on how it should be implemented and requirements, risks, mitigations, and so on.
Yeah.
And we are seeing that this is in a .taskmaster subfolder. So maybe you can explain a little bit more what Taskmaster is. How would I install this? And yeah, how did you import that Markdown file? Did you just throw it there, or is there a usual CLI tool that you use, or how that works?
Yeah, so in this case, Taskmaster is an MCP service as a kind of like as a add-on tool to Claude Code or any other agent you're using. And actually, it's not really necessary to use Taskmaster per se. There are other tools like BMAT configuration or SpecKit. The idea of this tool is kind of to help you do requirements engineering to produce a well-crafted product requirements document, which is the name for this longer story. And then what this also tries to do is to do the planning together with you, like the planning that you will also do in Scrum and so on. It will break down the PRD into tasks so that we have like a very good plan of what the AI should implement. But we as humans usually also do that, right? So it's just doing the planning step that you would as a human do usually in a planning meeting, and it is doing that as an AI for you, and file-based, creating a lot of files, yeah.
So to clarify, MCP, for me, this is kind of a SaaS, like Gmail integrating with Cloud Desktop or something. But this is something entirely local, or is there a SaaS behind it?
No. So the idea. So let's look a little bit more into the context here of what we currently have in the context in Claude Code, right? So you can use the /context command, and what you can see is that there are system tools in here, and then there are also MCP tools available here. And the ideas behind the system tools is that these are tools that are running locally on your machine, like searching files, editing files, anything like executing a CLI command in your shell. So anything the agent itself would invoke on your machine.
Yep.
And the idea of an MCP is that this is kind of a tool as well, but it's more a generic tool. It only needs to speak MCP, and then you can plug it into your agent. And the idea is to have that running somewhere on another computer, right? So invoking a tool on a different computer is the difference between the system tools. But people figured out it's also a nice way to kind of configure which tools are available to your agent anyways, like even locally. So as you can see here in my window, I have a JetBrains MCP server as well. This is a MCP server that helps Claude to navigate and use my JetBrains IDE. So it can, as I am using as a human, it can now use my IDE to invoke certain functionality of the IDE, which is super helpful. And Taskmaster is also a tool that can be invoked locally via MCP. Or even locally via CLI, and this is how I'm doing it here. So I'm kind of using the CLI version. We could dive deeper into why, but maybe later, or maybe.
But the installation procedure is just like any CLI tool. Like I don't know. I think this is a Node.js thingy, so you do npm-g install Taskmaster, and then
I think it's something like this. Like bun, I'm using bun, or you can also use npm, and you see like npm install Taskmaster AI, or bun install, and then you kind of can invoke it here on your CLI.
But the logic that it does, as far as I understand, it's really just a bookkeeping tool, like a Jira that is based on Markdown. So it kind of has maybe some opinions about the flow, but there's no magic AI in there. There's no kind of
it's more no. There is because it uses kind of AI to kind of it sends, for example, when creating the task based on the PRD. It kind of sends the PRD to an LLM, and adds a prompt and a system prompt and so on. So some internal ideas, what is a good prompt to break it down to tasks. And then it spits out this JSON of tasks. So it is a agentic system, but I don't think that we should kind of like, you could easily build that on your own. It's just a few prompts, right? And the idea is only I just didn't want to figure out what are good prompts for that, and so I just used that tool and started with it.
Yeah, it makes complete sense. I'm just trying to wrap my head around what kind of animal that is. Is it like a CLI tool that is just a Perl script, or is it something that comes with an LLM? And
it's an agent. So it's also an agent system. You could even use a different Claude Code instance to do that on your own by prompting a few prompts and say, well, I have this PRD, now please create task out of it and output it as a JSON, and please include these files and so on, these attributes, and then you will basically have the same functionality that Taskmaster is offering.
Yeah, that's really great hint here. I think if we want to do that the first time, then installing Taskmaster is maybe not the easiest approach. But just like kind of, I used to do that with ChatGPT a lot, where I'm creating Cloud Code prompts out of conversations with ChatGPT. So it's basically provide a good description for the task so that Claude can kind of go ahead with the implementation, right? That's the high level idea.
Yeah, I think what you could also add is that it was kind of also in the early days. So Taskmaster was one of the first tools to do that. And back in the day, like 10 weeks ago, what you did is you every MCP was for everything, right? And so they built an MCP tool out of that. Nowadays, people are kind of like a little bit more cautious what to build as an MCP and what not. And so StackKit, for example, is more of a prompt library and providing some customized and saved prompts for you, which are called commands in Claude Code. You can actually like invoke them with slash and then say this context thing, for example. It's a system command, and they are more of a command library now, these tools. So Taskmaster is in this regard a little bit different, but they also provide commands. So they kind of try to do both and like a comprehensive library for that. Yeah,
maybe also a command is basically just a prompt that is kind of loaded, right? Or is it
we will invoke a command here now. Maybe this is a good time to do that, and then I can also show the command. So what I'm going to invoke here is I'm going to invoke the implement next task command, or some say a saved prompt or a stored prompt. And this will actually implement our next task here from Taskmaster and actually write the code as well. So we should probably invoke that now so that the agent can implement our feature, and we can, while it is doing that, we will talk about what is going on while it is implementing. It's like great. It's like all the managers are doing, right? The developers are developing and the managers are talking about what they are doing. But before we look more into what is happening here, I can show you the command. So
exactly. So just for the listener, Benedikt just typed /impl minus next minus task into Claude, and then Claude started doing its thing. So you want to know how that kind of maps to something.
Yeah, exactly. So how does that map to what is going on? So in the folder that I was starting Claude in my project here, I have a .claude folder, and in the .claude folder you can basically put a lot of stuff in there to configure Claude. And one of these things is the commands folder where you can place your commands, your custom commands. And I opened one here in the background, and this is actually the command that I was invoking. So this is basically only this. I could have copy pasted that from the file into the terminal and return. So press return. So it would have been the same thing, but it's easier to do it with the command / thingy.
That was a big kind of flash moment for me. So this is a markdown file, right? This is not even a program. It's just a markdown file with very detailed information and kind of some context, some general approach things. And
I didn't even write it myself. So I told Claude to write me a command to implement the next task, and like a good command for implementing features in this setup here. And then it figured out, okay, we should probably do a few steps, and all these steps are described in the file here in the prompt. So it's basically a command or a workflow process written in English, like a development workflow. Like you can see here, like loading the story and then analyzing the code and then kind of starting in the implementation phase, first implementing a red test and then doing the green. So we are doing TDD here. And it's basically describing this workflow. And that is also what you can see here in the terminal now, right? It started by kicking off an orchestrator sub-agent, and we will talk about sub-agents in a second. And the sub-agent then told Claude Code to kind of do the research now, and then it kicked off multiple researching agents doing a lot of research in the background before implementing. It's like a developer would do as well, like first figuring out, I mean, I don't know this project, right? So I'm trying to figure out how are the patterns, what are the ideas here, where do I even start? And this is what happens here as well for the agent.
Yeah, one thing maybe to highlight here that I also kind of learned in previous versions of that conversation was just like how like a big part of the magic is just moving from a conversational experience like ChatGPT gives you on the nose to kind of just having a command line in a folder with kind of subfolders and directories. So you can just direct Claude Code always to kind of open certain files, read certain files.
Yeah.
You can store certain prompts that you know kind of are good. Usually when I'm at ChatGPT, I just tell it, hey, do this and this. And then I have to remember to kind of give it this instruction because I know he will kind of put too many EM dashes everywhere. The writing style is never what I want it to be. So like I had experimented just with markdown files, which I keep on my laptop, and I copy paste them just to have like stored prompts, if you like. And but of course, if you have like a real orchestrated version of that that is like available via commands and so on, this immediately gets a lot more useful. And I think this is like a good part of the value, actually, that we are just kind of having this context management that is kind of discoverable also for Claude Code, right?
Yeah. So, I mean, what we talked up until now is kind of, so this is like the project with a legacy project with the Claude Code configuration. And we only talked about the command part. So the other part was more like that we have the story and we did all of that already. But let's maybe look a little bit more on how I configured Claude here and what is it actually doing. Because commands is only a very small aspect. Commands is more for you as a human, I would say, because you need to manually invoke them. Claude Code is not itself looking into the commands and then saying, oh, well, this is a nice command, let me invoke it or something like that.
Yep.
So this is more like the starting point. And you could obviously like write a lot of commands for certain steps, but what you actually want to have is you want the agent to do these steps automatically, right? And that is what I try to do here. I try to only have one command that is doing the whole implementation workflow, and the rest is going to be automatic. Like even the committing and the pushing and the branch pull requests and so on. It's all inside this workflow without me needing to invoke it manually. So that's what you also meant in the beginning with it's highly opinionated, right? It's my way of the workflow, and other teams would have different ways. But yeah, this is like how I like to work with this particular repository here. Yeah, you mentioned one thing that like for the chat in the browser, you actually don't have this way of automatic context. So you can configure a little bit in your user settings that who are you or what do you like. So there's a little bit of a text field where you can add stuff. But here for the in the command line version, you actually have this Claude MD file. And the Claude MD file is a very important thing to do context management and to set up this whole system. Because in the Claude MD file, you can introduce a lot of information into the agent automatically. So when you start the agent, and we can show it here in a separate window, it automatically loads this Claude MD file. So you can give it your basic information already. So you can see here that we have a memory. So I just started another instance of Claude Code, wrote context, and you can see that even though I haven't written anything yet as a prompt or anything, there's already 10K tokens as a memory file. And this is what it's loaded from Claude Code, from the Claude MD file. And you can actually see that down here as well. It tells us to, okay, I've loaded this Claude MD, and I also loaded the README and the package JSON, and they are kind of all in my memory now.
What does memory mean here?
Yeah, memory means, so the agent itself, when you open it up, it's kind of like, it doesn't know anything in terms of when it does a request to the LLM, it only provides the LLM with your prompt. But it does not do that, right? It has a system prompt part that is from Claude Code itself. They wrote a nice system prompt, so it sends my prompt and the system prompt. And it also sends the system tools list so that the LLM knows which tools are available and can answer with, please use this tool. It also sends the MCP tools that are available and some other configuration from me. And it also sends this file, this memory file, this Claude MD file content. And then when I do my first prompt, it sends all of this to the LLM and not only the prompt itself.
Okay, got it. So it's ingested into the context window essentially.
Yeah, into the API request to the LLM.
Yeah.
And what I like to joke about is that these LLMs, they aren't actually that smart in a sense that you always need to provide the answer already. So the answer to the question needs to be in the context you provided. Otherwise, it will not know the answer. It will hallucinate something. Or it is something that is generally available in their training data, but the training data knows nothing about my project, right? So I kind of need to put all of my files, folders, everything that this LLM will now need to touch. I need to put it into the context window, into this request, in this format of just data, like text, and then it will kind of figure out the right answer based on all the information you put in there. Yeah.
But this is kind of, I think, at the crux of a lot of the this software development we want to do, because the whole source code listing could be like tens of thousands of lines, right? So maybe even megabytes of code, a few megabytes of code. So putting that into a context window is just like, this is too much for the LLM to chew. So likely we are like summarizing things, we are giving pointers or describing abstractions. We are not kind of just feeding raw data, right?
So I think that, I mean, the agent is kind of trying to fix that, right? The agent pattern is trying to work around that, because the agent can do tool invocations on your machine that they do not need a context for that, right? So when you kind of ask it, I want to implement this feature, and then it first doesn't know anything about the project, and it sends a request to the LLM, and the LLM returns something like, okay, I don't know anything about this project, but please do a tree command on your CLI so that you can send me the files that you have there on your machine. And then it sends the files with it. And then the LLM answers, okay, now please open these 5 files and look into those, because those are interesting. I don't care about the others, but for this feature, those are interesting. So it kind of, so the idea is you don't need to feed all of your code in there, but it will kind of figure out, like a human, you don't also need to know all the code, right? It will figure out which parts are important. And with a Claude MD file, you can actually provide more hints, like which files are important for which use case, like where's the front end, where's the back end. So you could kind of guide it a little bit so that it doesn't need to do that many iterations internally until it figures it out. It's kind of like a fast track, you could say.
Yeah. This is, again, something that I think is very similar to humans and to LLMs, right? It's really like you have a PhD level new employee that just doesn't have any context. So you can send him off with the printout of the code and no comments and no documentation and say, figure it out. And then he comes back 2 weeks later and says, okay, I figured it out. What do we want to do next? But it's not very efficient. So maybe you want to write some documentation or do some onboarding or have like an architecture diagram. So you
have a tool like an IDE, right? Like an IDE will help you as well.
That's true.
Like, and that is kind of what tools in the LLM are also doing. Like it provides you an interface. You can actually
Yeah.
work on these files easier than not having any IDE. Yeah.
Yeah, maybe we can go to this kind of additional context things, because I think that is kind of one of the very important things that I learned, which is like as a human, you are kind of giving this additional context to make good decisions, make good architecture decision, write good
Yeah.
codes. You actually need a little bit more knowledge.
Yeah. I mean, good is also like your specific idea of good, right? In your specific environment. So the LLM itself that knows what the world perceives as good for architecture rules, but this might not be good for you. Or as we know, like a lot of code out there is not very good. So it's also probably not very good in general. But yeah, so the idea is that you need to configure, or you need to provide information what is in your specific environment, good code or good practices and so on. And what's quite interesting that you ask it now, because my agent here actually stopped and it didn't implement anymore. And I can tell you why, and that relates to what you were saying. And there's an interesting thing about context here in it as well. So let me explain a little bit what happened and then come to this context conclusion. So the workflow orchestrator that was kicked off in the beginning was telling my agent to do a research phase or start the research phase. So it started researching. It started to look for documentation in the project. It started to look for code patterns. And it kicked off a different agent, which is called Architecture Advisor. And that Architecture Advisor agent that has all the information about what is a good architecture in this particular context here. And then it provided, so these agents, this research phase collected all of that and provided it back to the main agent, so that the main agent now knows about the stuff that it wants to work on. We can also go a little bit more in the technical details of the sub-agents later, but for now, let's look what happens next. So next, it kicked off the implementation of the red test. Because we are doing TDD, it starts with a test that will fail, and it then again invoked another sub-agent that's called Quality Assurance Expert, and that will help with writing a very good test. So the quality assurance expert will look at all the code patterns again and so on, and has the ideas of what is a good test, what are edge cases and so on, and provides the main agent with the information that it actually should implement, which tests actually to implement. And now it's super interesting. Yeah, go ahead. Yeah.
I think this is on the meta level is quite interesting, because naively I would have thought your command basically said, hey, Claude, please implement this feature with those guidelines. But that's really not what happened, right? We kicked off the sub-agents. And so maybe you can talk a little bit about the sub-agents, how this orchestration works, how those agents are defined, and how the kind of interaction really is, because we are kind of going really into the agentic software engineering.
Yeah.
Right?
Yeah, so usually when you would kind of implement a feature in a more work together way, like interacting with the agent and not letting it do stuff autonomous, you would be more in control which context to provide, right? So you would kind of say, I want to implement this feature now, and please read those files, and please also read this documentation. But in this case, we don't want to be in this interactive mode, but we want to let it do these things more automatically and more autonomous. And that's why we only provided a workflow. And also in this prompt, I also provided the workflow, what to do. But I also provided some additional agents. And the workflow is kind of at the moment when it needs the information, invoking this different agent. And the different agent will collect the necessary information. For example, when we look here at the pattern analyzer, it is again kind of a markdown file describing what this specific agent, what the purpose of this agent and how it will do that. And the purpose here, I mean, we don't need to read all of that, but the purpose is like, look at the existing code and figure out if there's something similar to what we currently want to implement in the code, and then tell me if you find something similar, how it is implemented. And that is what actually happened here in the agent, right? It was invoked here with analyze value object patterns in the code, and then it answered back with the patterns for the specific implementation of how in the current code value objects are implemented.
Let me just highlight this real quick. So what we are seeing is .cloud agents pattern analyzer.md. So an agent is literally, again, a markdown file with there's a header there, and it's kind of just describing behavioral rules for the agent, right? And
Yeah.
because it's sitting there, kind of Claude knows how to invoke the agent. And am I correct that it kind of forks a subs instance, or it just creates a blank instance and loads that, or how does this kind of
Yeah.
invoking an agent work?
Yeah, so the invoking of the agent is, what we would probably need to start with is sub-agents is a very specific feature to Claude Code. So other agents implemented this a little bit differently, but for Claude Code, it is kind of like a own sub-process, or actually like a completely like a different process with its own context window. And we are
Clean
we are
context window or a pre kind of filled context window?
No, it's clean. So it starts. So it we can sadly not look into it as we can look into the context window of the main agent, but the sub agent has a clean context window. It doesn't even load the ClaudeMD file. It only loads basically what is in here in our agent definition file. This is loaded and it receives a prompt from the main agent. So we don't prompt it, but the main agent prompts it. And that is what you can see here on the right. This is the prompt that I highlight here. So the main agent that I was talking to, that I was invoking, now invoked the other agent with a prompt and saying analyze value object patterns as a prompt to this other agent. And this other agent then returns an answer back to the main agent.
So very small prompt, no, only, like really just 4 words.
Yeah. So, I mean, it depends on how you configure the sub-agent. Like some sub-agents also take like more complicated prompts, and you also need to provide a description here on top of the agent that will tell the main agent how to actually prompt it. But in this case, I only use it so the prompt can be very tiny here because I have all the necessary information in the system information here of the sub agent. Basically, the prompt could have been just do it because everything is here, and I'm only doing it because as you can see here on the side, it takes a massive amount of tokens to do this analysis. And we don't want to fill these tokens in our main agent's context window. So what happens here, I just offload, I delegate the token usage, the context usage, and then only receive the necessary information back to my main agent. So when we actually do context here again in our main agent, we then can see that there's only like 130K used, and these agents already like 40K, nearly 50K, 50K, 50K. So they already burned a lot of tokens, but we don't really get all of these usage. And that is a very meaningful way to kind of manage your context and to let these agents kind of help you to not fill your context that quickly, because you want to only fill the necessary information in your context and only at the time when you need it. That is like also a big problem when you define something in the beginning, it kind of forgets it. Like you as a human, you read a book and you are on page 200, you don't know what's on page 5. You just don't. But if you're on page 7, you know what's on page 5. And yeah, that is basically the idea here as well, to invoke the agent at the exact moment you need the information and let it only return the information that you need so you remember it. And you're then very much focused on the specific task. And to actually like look at what it did, I feel this so amazing. It actually like wanted to implement the test now, and then it says, well, dear nice human, you provided a contradiction here in my context. So in your documentation, you're clearly mandating to use factory method pattern to implement as an architecture standard to implement value objects. But when I look at existing value objects, you actually don't follow the standard. So
surprise.
And then it says, well, what the fuck should I do now, right? So should I do this or should I do that? And I think this is like a very interesting thing. These contradictions are super nasty, because contradictions are not only bad for you as a human because you don't know what to do, but also bad for the agent. And they happen quite quickly for the agents because you as a human, you don't really know all the files and all the stuff, and it's like so much to read and so on. But I really like that it asked me here to kind of, what should I do now, right? And now I need to prompt it so that it continues, and I'm going to say, please do the one that is used by Produktname and continue your implementation. So I'm just saying it, okay, well, I know that there's a decision record that we should do a factory pattern, but let's keep it like the others are implemented. And that is what is now happening. It says, okay, thank you so much. Now I know how to follow it. And he actually mentioned that he's going to follow it because it's better consistency. So it kind of ensures me that I made a good decision, but it's always doing that. So it doesn't matter which decision I would have made, it would always have said that it's a great decision. Yeah,
they like to please.
Yeah.
Yeah, that's actually pretty cool on a meta level, that it doesn't just go brr and does something, but it kind of identifies that and surfaces this. I mean,
Yeah, but it did that not because, sorry to interrupt you,
Yeah.
but it didn't do that because it's a nice agent or a nice human or anything. It did that because in my Claude MD file, I actually kind of have some principles to adhere to. So I said there is a section here, core directives, where I try to give it a little bit more of a personality and say, okay, you are like absolutely truthful and you need to be evidence-based and please. And then there's a section around hallucination prevention. And then there's this, say, I don't know when you are not confident, and say, I need to verify, and so on. And because of that, I was kind of reinforcing it that it's okay to kind of tell me that it doesn't know and that it needs more instruction. Usually these agents try to do it on their own and not say, well, I don't really know. So that's why I put that into my context that is automatically loaded, so that it will ask me and kind of clarify what is going on. Yeah.
Are you kind of using any kind of special commands to make it kind of go so long? Because
No.
yeah, what I realize is when I ask Claude, it usually comes to me after a few seconds and says, here is your change. Do you want to review? And what it does, I mean, I know about the auto accept feature. I think that is something. But it kind of, this can, I think, go for 10, 15 minutes after you kind of send it off, right? And consume.
Yeah, this can go for hours actually, even.
Yeah.
So what I do a little differently is that I switch into a mode called bypass permissions. It's like the YOLO mode. It's like quite dangerous, but if you have a correct setup, then it kind of is okay-ish, I would say. So it doesn't ask me if it's okay to invoke certain CLI commands and so on. I let it just do that, and then that's why it's not asking me. But what you could also do, there's a settings JSON, a local settings JSON file where you can actually allow certain commands. And after a few iterations, this list will be very, very long, and you will probably have covered all the commands that are allowed. And then you can actually also kind of instruct Claude Code to only use available and allowed commands, and do not ask for any commands that are not allowed yet. And then it will continue on its own and not ask you for any commands that are not on the permission list or anything. So you can make it kind of run longer, but the idea is if you bypass any permissions, it will not ask you for anything.
Yeah, that's good to know. Potentially.
Yeah, the worst thing that happened to me was it deleted my local Git history and then force pushed it to the remote repository. So the history is completely wiped. But I mean, I had a different copy of the same project in the backup, so I could force push the history back into the remote branch. But I mean, that was actually also on the main branch, so not very great. But yeah, so it is dangerous. You shouldn't just let it do that without you having a good idea of what the configuration of your system is, and that you have a good idea of what it's going to do. So yeah, that's basically, or you can do it in a certain secure environment like a dev container or a GitLab instance remotely. So yeah, it's kind of
Yeah, you can isolate it if you really want to. Just a little service. There is a git reflog command, you know it, and likely you had the full .git nuked. But in many situations, even if you force push or so, you can recover the object as long as you didn't kind of remove the object store, and that is usually cleaned async. So even the upstream should have the copy in that case.
Yeah, I think so as well.
Yeah.
But I mean, there are other dangerous things, like right,
Of
if it for example has some possibility to use a CLI to access a database, and then it's probably maybe even a production database, and so there can be a lot of stuff going on, right?
I mean, it has access to Bash on your local host, and
yeah,
yes,
yeah,
like
and
a
it can
lot of
invoke
stuff.
any command there, like any command. It's no, it's allowed to bypass everything, so it can invoke any local command, like remove my system folder, but it would not do that. I mean, these models are very, very good at the moment, or now that they won't do like shitty ideas. But yeah, you should be aware of what you're doing. Yeah.
Yeah, there's attack surface, but it's like unless there's somebody really has an angle there, it's very unlikely that something that is actually going to happen.
Yeah.
Okay.
Actually, quite nice in the background. What we see here in the background now is that it actually implemented the red test and also the code. So it now is in the step where it wants to refactor, right? Like red green refactor is the great rule of test-driven development. And for the refactoring, it started again a new sub-agent, and the sub-agent is now analyzing the code that was written and provides some refactoring advice. And there's, again, a new thing that is great about these sub-agents. Because they are new agents, they are not the ones that wrote the code. So when they provide criticism to the person who wrote the code, then they will be better at criticizing it. If you would do that in the main agent, it will say, well, it was great because, I mean, it implemented it like a developer would do, like a human would do. That's my code, it's great, right? So yeah, it's kind of nice that you can use these similar patterns here as well. Yeah.
Yeah, that's cool. I don't think I've done much test-driven development. I usually do it the other way around, like maybe red test, then refactor until the feature becomes easy, and then make the test green. But I can see why the other thing does make more sense.
I mean, this is a point as well, like how do I like to use these agents? So, or this AI in general. So I try to use it in ways that it will actually create more quality, and doing that without causing the teams to be slower, right? And test-driven development is something that you usually do not do, not because it's not technically possible. You can make it possible, but you are actually, as a human, you are quite skeptical, and you're like, yeah, well, I don't really like to write tests, or I like to think about the solution and build something and so on, which is totally, I mean, I'm the same, right? It's totally fine, but the AI will actually, if you tell it to write the test first, it will do that, and it will not complain. It will actually do that, and it's actually helping the quality of the implementation, not only for you as a human, if you would do that, but also for the AI, because it now then only produces the code that will make the test green, and it will not produce thousands of different classes and lines and tries to implement the whole feature at once or something. It will only make the test green. So it will make a very surgical thing. I mean, you as a human would do that anyways without the test, because you learned to do it like this. But the AI is more verbose usually, and it tries to do a lot more. Yeah, and that is why I really like this TDD approach for the agents. And we don't need to stop here, right? Because there's other things that we humans usually don't really do a lot, right? We talked about the refinement of a user story. Because when we refine a user story, we do a refinement meeting, we talk about it, we all have it in our heads, and we move on, but we don't write that down. And when someone is sick or someone is in vacation or the person wasn't in the refinement, we kind of have a problem in our process, because the person needs to be told what needs to be done, and that costs a lot of time. So what you can do is you can leverage an agent to enhance your user stories, and take the transcript of the refinement meeting and then write an actual PRD with a lot of information and push that into Jira or as a markdown file or wherever. But this, again, it doesn't really cost you more time because you will do the refinement meeting anyways, and you would need to document it anyways as well. But now you can just use the agent to let the agent document it for you. And because you have spoken about it and you have recorded the transcript, the agent will not hallucinate. It will write down what you were talking about and not come up with ideas that are not real. It will even be better than you because you can actually say, hey, and look in the code if we missed something, or look in the code if this is actually also reflected in the code like we are talking about it, or if there's something that is not like this in the code. And I mean, developers usually try to do that in a refinement meeting, figuring out what is the current implementation, like is that doable or not, and comparing it in their head with the current implementation. But that's very hard. I mean, you need to know all of the 3 million lines of code in your head, and you will not know all the edge cases, right? But the AI can then verify that in this process as well.
Yeah, this goes into into this direction of how do we kind of take things from the brains and feed it to the machine. And like one trick they actually learned also from our last conversation, just use voice a lot more. So there's this whisper tool. I have it now like F12. If I need to type something, specifically prompts, I'm always there, and then I'm just speaking to my microphone, and then it kind of becomes text. And just having the AI listen in on conversations, that kind of is a low effort way to kind of scrape some information of that kind of a layer. And then you have maybe chat conversations that you can copy paste. Copy paste is always easy, or you can always take a transcript that works. Getting that fully integrated and compliant and so on, there's a different story. But like the technical capabilities are there. And then I think we are getting into what's also a very human activity, which is summarizing. You probably don't want to check in the kind of raw transcript of all the meetings that you have. Like that's, I mean, you can do it as a raw data source, but I think you do.
I mean, why not? Well, you could, right? But so.
I mean, it's as you just said, I mean, there is real cost to just polluting your context with too many words. So if you want to extract information out of that, having the summarization does make sense. So maybe you want to keep the raw material as a kind of source that is authoritative source. Like in a data management system, you sometimes have these import tables that you keep around, and you work them with the refined information. Maybe half a year later, you are redoing the import. But my impression is that the sweet spot is maybe a kind of meeting notes folder where you have the summarized information, or this ADR folder, I think, that you also have here, where you are kind of extracting decisions that you made and documenting decisions in a relatively standardized form. So then once you, as an LLM, want to load the context, or maybe even as a human, you can find that easily and get the TLDR of that.
I mean, I would suggest a different approach. So I would suggest that the question is, when do you need this context? So when you implement the story, like we are doing right now, like generating the actual code, you probably don't need these transcripts anymore because they are not helpful for you. When or if you have a story that has all the information that you need. So the story is kind of the summarization for you for this step. Because the story contains all the necessary information that you need. But to produce the story, you kind of have a different agent, and that agent might need the whole conversation because this is like very helpful to have not the summary, but all the information of it. So my kind of idea on how to manage this context is more to kind of have very focused agents for specific tasks and give them the context that they need. And I think it's quite hard to say, I have a text, a transcript of a meeting, and then I summarize it. But the question is, summarizing for what? So
Yeah.
do I summarize it for doing this or for doing that? And that will kind of implicate what I'm going to remove from the whole thing. And that is actually an interesting conversation as well, not only for this transcript thing, but also for compaction. So
Yeah.
let's maybe also look into that topic for a second, because Claude Code has the same problem, right? So Claude Code is working, and it's working, and every agent has that, and the context gets fuller and fuller. And you were kind of ahead of that already, right? Like, oh, when I have the transcript and this and that, then the context is going to be full, and then kind of there's too much stuff in there, and then it needs to kind of start with a fresh context window, which means it forgot everything. And it needs to pick up on the information it needs for the task that it's working on again. But it probably also forgot which task it is working on, right? Because it lost all its context. And in the context is the information which task I'm working on. So how do I actually know what I was doing? It's like a new human, right? So one person leaves the room and the other one comes in, and it's like, well, what's going on here, guys? Like, I have no idea.
The Men in Black good stings thing.
Yeah, exactly. The good idea, good thing. Like, and you don't know anything anymore. So you need to figure out, what do I do, right? And the current idea of how to cope with that is to do something called like a compaction. So you take the current person, you summarize what the person knows or what the agent knows, and you kind of stuff it into the new agent in the beginning as its initial context, so that it then remembers
Some things.
some things. Let's say some things.
Yeah.
And now the question is like, what things should it remember? And that is a very hard question. And for a while that was very, very it didn't work very well. So this compaction was always like, please don't. If you ever see it compact, you're screwed. Like, nothing is going to happen anymore. In the newer versions, it got better, because they kind of, as you can see here in the background as well, they kind of provided more space as a buffer to do the compaction. Because if your brain is kind of full and you should now do a compaction or a summary, it's kind of hard to do it because you don't have any space to do that anymore.
Yeah.
So what they kind of introduced is a compaction buffer. So to have some place available for the compaction. And you can also give the compaction a more directed message, like, what is this thing that you want to do next or after this compaction, so that it compacts for this specific reason. And it will do that automatically as well, because it kind of creates this internal to-do list, and then it knows the next to-dos, and then it kind of knows, okay, I need to still do these to-dos, so I give that into the compaction, and it will do a fairly okayish compaction. So it's working better than it was working before. It's still easier to kind of just write your current information or your current state into a markdown file on the system again, and then the next agent just reads this file, right? Because then you have more space available to do so you can write more files than you can put into the compacted kind of space, and the new agent can again select the stuff from the saved files, which is interesting to him. It's like a log, right? An access log. Every conversation that was made, every step that was made. That some people do that, or try to, at least on a certain level, write these logs into markdown files and then throw them away when they are done with everything. Yeah.
Okay, before we go on, I need to go on a bio break. Should we just take 2 minutes and then kind of review the code that the Claude thingy wrote?
Yeah, I think it's a good idea. I can talk a little bit about the next iterations in Scrum as well, right? Like a retrospective, which is also a nice thing we can look into.
Let's do it. Then we just go offline for a bit. I will cut this out, and I see you in 2 minutes. All right. I lied. I also got myself a new coffee and a little bit more water.
Yeah, I also drank something. Yeah.
Nice. Okay, then let's continue here. So, how does Claude look? Are we through with the task?
Yeah, we are nearly done. I think it's at the state where it's reviewing its own code. So I think the last time we looked here, I was talking about the refactoring step.
Yep.
So it was doing the refactoring, and let me go here and see where it is. Where is it? Okay, it's not that easy to find in all the messages, but I think it did the refactoring, and then it did a documentation of its current status, what it built, and so on. And now after that, it did something which I call memory here, and maybe this is something that I can talk a little bit more about in a minute. It also committed already, and now it's validating that it actually built the stuff that it should have built. So like this review is not a code review; it's more like the Scrum review. Because what I try to do here is I try to kind of look at the full software development lifecycle and say, okay, I don't only want to implement the part where we build the code, but also doing the retrospective and also doing the product or the Scrum review. And sometimes it happens that the agent kind of deviates from what should have been built, and the review will ensure that it will kind of check, like we as a human do as well. We check if we actually built what was in the story, and if we realize, okay, shit, we didn't, then we kind of start over or we correct that. And the memory part is a little bit similar to what we do in the retrospective. So when we humans, when we do Scrum, we meet every 2 weeks or every sprint, right? And we say, well, what went well, what didn't went well, what should we change for next time? And for the agent, I feel that we kind of want to do the same thing. So we have the configuration of the sub agents, we have the Claude MD, we have additional context information. And now what we want to do is we want to improve that over time so that the agent gets better and better and more autonomous. And to make that happen, I do a retrospective with my agent. So each session, I let it write a file to the file system. In this case, I provide a template to do that. And it did that here in the step here. You can see it here. It wrote an episode file with a timestamp and the task ID, and kind of documented what was going on. Okay, so what was the problem in the beginning, challenges that were encountered, and then it also has this part where it is doing something like what we know from a retro. What went well? Oh, sorry, my trash pad. What went well? What could have been improved, and so on. And the idea here is that I do that every iteration, like every time I let it write a code, I get more and more episodes. And every 2 weeks, when I do my Scrum review, I take out my agent review, other agent, and that will look through all of these episode files and say, okay, is there a pattern? Like, did something go wrong a lot in these episodes? And is there something that we should add to our context or something that we should change in our environment set up here with the sub-agents and so on, that these errors will not appear anymore? So it will make an improvement proposal. We will make the improvement, and in 2 weeks, we will see if it worked or not. Is it less in the episodes now, or is it more in there? Did the improvement help anything? So there's kind of the same idea of a self-improvement like we humans have. And obviously, this is kind of like a very human way of doing that. So actually, you can also scale that out and have like multiple agents run stuff and then compare that and so on. So you can very much scale that. But my first goal is always to kind of create the acceptance and the adoption also in the team and kind of integrating it into the existing process. So I don't really want to scale it out yet because I feel that we are not there yet. So it's too overwhelming and so on. So let's keep it very integrated. And this is, for me at least, a very nice way to improve it without being such a burden or an overhead in the actual usual processes of a team. Yeah.
Yeah, it's also kind of one of the meta things that you usually don't have on the radar. I mean, the obvious thing is you iterate on your prompts, right? You get certain results, and then maybe the next time you try it, you may make a change. And basically, this is okay. You let Claude suggest improvements or identify improvements, and then you basically say, "Hey, maybe you want to improve your own prompt to do this better next time," which
Yeah.
is some next level shit.
Yeah, and I mean, it is also not only looking at the prompt, right? So the
Yeah,
prompt is one of the aspects, but the other aspect is the sub-agents,
yeah,
the context files, and so on. And also, that is something that when we review the code now, we will figure out that it actually took quite a while to do small changes.
yeah,
And this could also be an improvement that Claude realizes, like, okay, well, we needed a lot of tokens here to do a small change.
yeah,
The reason for that is that I have an agent system configured here that will demonstrate all the features that there are. So it's kind of over-engineered, but also I don't really want to create different configurations for different levels of stories. So if it's an easy story, it's still okay to let the senior do it, or the person that is like taking longer and so on. And if it's a hard story, then you still have the good setup, right? And at the
yeah,
moment, we are not at the optimizing phase where you can say, okay, well, for this task, I use the easier system, and for this task, the harder system, and so on, the more
yeah,
optimized one. So the idea is basically, however the hard the task is, this system will be able to build it.
yeah.
And yeah, that sometimes it looks a little bit slow or expensive. But you also still need to remember we were not doing anything here, right? We were just talking, and it did it on its own. So I think if it's like an hour or if it's 2 hours, it doesn't really matter, because we didn't do anything, right?
Well, the most important
Yeah.
bit is that we get a high quality code out of that, that we can review the code now and just
Yeah. Let's
see
do
if
that.
it kind of makes sense. And then it's just like, okay, this is how much like developer would cost, and this is how much like a machine is,
Yeah.
or close a machine is able to come. Yeah.
Yeah. Okay, so let's start by looking at the commit message, because part of my workflow was to commit stuff, and it actually wrote a very excessive commit message here. So I mean, it's much longer than a human would do, and that is actually still one issue as well. So there's a lot of, it's really hard for the AI to figure out what is too much and what is exactly right. So it creates a lot of slop when, for example, you want to make it write a documentation or a commit or anything like that. So what I see here is I should definitely improve the context where I instructed how a good commit message looks like, because this is way too much and also information that is not valuable for me.
I
But
mean,
still,
we are
yeah,
looking at maybe 3/4 of a
yeah,
page. It's not that excessive. It lists features, it lists some technical details, it lists files, it lists okay quality gates. So maybe a little bit on the verbose side, but I would say not terrible. And there is a commit message. Hey, it's not
yeah.
just like PR implemented or whatever. Yeah,
Yeah, you're right. So,
yeah,
I mean, you could see it from both sides, right? You could either say, well, this is like very much, you could see it negatively and say this is like way too much, or okay, it lists the files that were changed. Like this is always something very bad in a commit message because you
yeah,
can see it from the diff of the commit. But yeah, you're right. You could also see it positively and say, okay, well, it actually also added some technical constraints or some. I mean, we had this issue with the implementation where we thought, okay, which path should I choose? And it actually put that in here and says, well, we were now using this particular pattern, even though it's not like in this or whatever, right? So
yeah.
this is like very valuable information actually.
Yeah.
So you could see it
So
positively as well.
I
Yeah.
would say 8 out of 10 for the commit message. And now let's look at the code. How
Yeah.
do you like the
Okay.
code? Yeah.
Okay, so okay, let's like not this. The task thing is not that important. The episode as well. Okay, so its task for its first task of this whole story was first to implement Beschreibung, so a value object to store the description in, right? Because we're doing domain-driven design, it needs to like implement some domain object, value object in this case, to store the actual Beschreibung. And it created a Beschreibung here that is very much looking, for me at least, very good. It has a variable for the max amount of characters that are allowed. This is actually stated in the user story. It created a factory method where it first checks if it's not blank, then it sanitizes the value, checks then after the sanitization, which is very good, because if you do it before, like validating the length before the sanitization, you will kick out some texts that are actually short enough, because after the sanitization, they will be shorter, right? So it validates the length after the sanitization. And if it's kind of rechecking the bank, so it's a little bit.
Let's not go too much into detail. I think we are looking at a like 50-line function or a class, like 43-line class. We have the Beschreibungstext, which is the string object, and then we have a bunch of validation logic. And on first glance, this looks plausible and also in line with what we ordered, right?
Yeah, exactly. And what is also interesting is that we can see that it also implemented a test. It was actually implemented first, right? And this test is, when we look into it, it's very exhaustive. So there's a lot of very well-written test cases. You can see here it even tests these script security thing for the sanitization. So I think that it did a good job here, right?
Yeah, it looks very good. It has also German text sprinkled in it. I think these are the function names, which are like descriptive. It checks for empty strings. It checks a lot of edge cases. And they are very clean.
Yeah, I think so as well. So I think I wouldn't have written better tests myself, I'd say.
No way I have written better tests than that.
Yeah, and also not that many. I would have been way too, like, how do you say, like, foul?
Yeah, I mean, for me, this is one of the things where I'm like, okay, I have this kind of many rules and I just trust my code enough. Then I just write the implementation. That's not a good practice, because it's not really future proofing. But if I had the ticket, I would probably try to write this not very test driven.
Yeah.
But I think the cost differential actually checks out here. I can write an LLM kind of all the aspects of the spec and kind of the good things that we want to have. You can write those things, and then we are just on the safe side. And if we ever touch the validation code, we know that at least those kind of knowable, foreseeable things are still okay.
Yeah, I mean, it's like the same for humans, right? If I do a refactoring now, or if I, for example, would say, well, the AI didn't write the object very good here, I want to change it, I still know that the tests in the background will cover that my refactoring will not make it break, right? And also the ratio is kind of nice. You have like 50 lines of a value object, and you have like 130-ish lines of tests. So it's like double the amount of tests. That, in my head at least, it's always like a good ratio to have, like in terms of test code and production code or application code. So yeah, for me, it overall looks quite nice, and we could instruct it to start with the next task now, right? And continue the implementation.
There's there are two other files. The exceptions. Okay, all right. So
yeah. So it actually wrote similar to the other value objects. We have domain-specific exceptions here, and it implemented it the same way that it figured out that there are domain-specific exceptions that should be thrown, and then it throws them as well. And what I particularly like is it also figured out that we kind of use German code for some specific, because we kind of thought, okay, it's a domain language, a ubiquitous language is German here. And so we coded in German as well, because the ubiquitous language is German. And that kind of figured that out and used these German descriptions and German names for the classes and for the exceptions as well. Yeah.
Okay, nice. Yeah, I mean, high level, this is, very straightforward as a feature, to be honest. And we didn't see the kind of maybe more interesting bits with the database integration and so on. Maybe that is the next task. But on a high level, we kind of went through a very thorough process, it was almost fully autonomous. There was no interactions. It took a while longer than expected. We are an hour and a half in at the podcast now. And we ticked this off at the 20-minute mark. So I think
and I think in between we kind of had a conversation where it was waiting for our input. I did idle a little bit.
So I think we could probably get this thing down to below like 15 minutes if we were tuning this a little bit, maybe 20.
Yeah, I think so as well. Yeah. And I already kicked off the next task, right? And when we are still talking. So that is what I said a few minutes ago. I always feel that we are not in the phase yet where we want to optimize it for like if it's 20 minutes or 40 minutes or something like that, because I can do different stuff during this agent implementing here. I can also already prepare a different story and make the, for example, I could be in a meeting doing the refinement for the next story while this agent is implementing. And this is actually like real feedback from teams I have in organizations that they, for example, the senior developers are often in meetings because they need to provide information. And then you can have like two fixes, like what can you do? You can use AI in the background, which is like, usually you can't code in the background of a meeting because you will not be able to focus on both things. But you can use an agent in parallel and let it do some stuff and answer a question from time to time for the agent. And you can also kind of try to automate yourself away in terms of what the questions are that you need to answer in this meeting, so that you also don't need to answer those, but an agent will answer them for you. If you have good context, you can just paste the answer in there and let it answer for you, which is actually happening. So I see that I had one of my clients, he was in a meeting where he was needed. Then he wrote code in parallel with the agent, and a junior developer was asking him on Teams what he should do about this and that. And he just took that, pasted it into his agent, and copy-pasted the answer in Teams as well and sent it off to the junior developer while he was in the meeting and the agent was coding his stuff. So this is kind of, okay, it sounds like a little bit of a cognitive overload, but because you don't really need to be in that stuff so deep, it's okay in terms of context, I would say, in terms of context overload, cognitive overload. Now I'm saying context overload, kind of the same.
Yeah, it's just our own LLM. It's almost the same.
Yeah.
Okay, Benedikt, how about we step a little bit outside of the code editor now and just talk more on the meta game on like how this is kind of used in practice, and how like this. Yeah, maybe this is really the point here. You already alluded to it. So in your practice, I mean, we ticked something off. It may take like 10 minutes to an hour until this comes back. So are you just doing different things? Are you in meetings? Are you having 2 or 3 agents in parallel that you kind of feed with context? Like, how does that work for you?
Yeah, I think that the part about the question that is actually the most important part is how does it work for me, right? And how do you use these agent, or how you use these agent tools heavily depends on your current situation. So if you are a solo freelancing developer building having a team of 3 people or something, then you will probably not need this Scrum thing, and you will not have like a process around it and so on. You will probably only work a very interactive way with your own agent, and have a chat and not do so much autonomous and so on. Or you would try to have a lot of parallel agents working on the project, because you can more easily like focus on those parallel things and what is going on and so on. And for me, I'm like in a little bit of a different situation, because what I come from a context or an environment where you have multiple teams working on a huge project, like often like 10, 16 teams, having like 5 to 6 developers each team. And what you need to be aware of, that there is like a whole organization around this coding part, and that makes me use it in a way that actually we've seen here. So I try to, I have multiple repository configurations, one repository for creating refinements, creating stories out of refinements, helping product managers collect the right amount of information so that the definition of ready is reached. And I have a configuration for that. There's mainly markdown files in there, right? Because you don't have code in this step. And then there's often a technical refinement step where you have all the architecture rules and so on, and try to add those information to the user story. You will probably provide the code there as well, like add this code as a separate context. So basically, what I'm saying is I have very specific agent configurations for each of the steps of a Scrum process, or even Kanban or Scrumban process, and kind of make the agents AI blend in this process and leveraging what is actually already there, trying to elevate it by using the AI. That is what I'm currently doing on a high level. Yeah.
Okay, I'm not quite sure I got that. But
Okay.
basically, what you are saying is you're not actually coding that much at the moment, right?
No.
Okay.
No.
So you are on
I-
one level higher and kind of
No.
help to orchestrate kind of tasks between the teams.
I mean, I'm also coding because one part of this is the coding. But what you do is in a, so maybe I can try to explain it a little bit differently, and then we can maybe cut around it.
Maybe the question is wrong. Maybe I should
Yeah, okay.
ask, like, if you are a senior developer working in a team, or
Yeah.
maybe one of your team members that kind of is assigned to a project, is kind
Yeah.
of on that project for 3 weeks. He has the same problem. Right now, he works in that code base. He has implemented this, or he's working on that. You wouldn't expect him to kind of move to a higher level task necessarily.
No.
He may have 2 or 3 tickets he could work on in parallel or do something on the project. But how would that work, and does it scale? How far does it scale? What are the problems you run into if you kind of start kind of filling in the time? Yeah.
Yeah. Okay. So I think that my goal, at least, is that the process of, or the daily day-to-day business of this developer will not change a lot. The developer will still have refinement meetings, have planning meetings, will also have like meetings with the stakeholder and so on. But the developer will actually be able to kind of shorten the feedback cycles, because the refinement meetings will happen much more often, because you kind of, when you let the AI implement these features and they are very well described, then it will only take like a few hours for what you usually would take a few days to build, because you are in meetings, you have different tasks to do and so on, and despite coding, and you can do the coding in parallel to the meeting or in parallel to other tasks, and so you can leverage the time while this agent is autonomously working. And so the feedback side is you will do more refinement meetings, you will do more planning meetings, up to a point that you will plan every day. So your day will start with the planning of the story that you want to implement at that day, and in the end of the day you will do the retrospective because you would have implemented the story.
Yeah, but let me poke this a little bit more, because what we saw was actually not a Copilot use case. We didn't kind of just code faster. So in the end, if you just say the senior software engineer is kind of using this workflow, which may even be slower than if he did it by hand, but it's kind of nicer and thorough, and he only has one agent associated to him or her, then will this really be a productivity benefit? Isn't the benefit coming from having those agents run autonomous, maybe having one senior engineer supervising at least 2, or working on something on the side? And the problem that I see is really this context switching that becomes very quickly, surprisingly challenging.
Yeah, I mean, this is one scenario. The question I think is like we don't really know which of the scenarios will pan out in the end.
Yeah,
People feel that, and we are also trying that for certain customers to kind of leverage, so to move from doing that locally into doing that remotely on in a pipeline or on some workflow engine system, and the results that we see are not that great. They are only good once you have the correct setup for this specific repository in terms of context and so on. And then you can move it to remote execution. But what happens then is the context overloading part, right? The cognitive overloading part of the human, because you run it in the night and in the morning you have like 6 PRs to review.
yeah.
And what do you do then? And then even if all of them are done and they are good and you kind of review them, you ran out of stories to implement. And then you have the problem that the product manager is not fast enough to produce refined stories for you to implement. So
That will be a happy product manager.
well, I don't know. So we have we had this scenario a few times already that we were kind of idling around, and then we had this problem that we and the product manager is kind of like under a lot of load then, because the team is idling around and there's a lot of pressure, like, oh, I need to fast produce, and then you don't think about, is that a valuable feature we should implement, or is that something that is kind of like, okay, we have time, we can do that now, but it doesn't really matter to the user. So I think there's a lot of downside. And well, okay, if you think productivity is just creating a lot of stories, okay, great, but is it a valuable thing for the user? Then it's actually bad again. So I'm really not sure which path is going to be the one that really actually help us in the end.
But what you describe is basically you remove the bottleneck. So I think one
Yeah.
thing that like for most part is actually holding true, that is really developer time on implementation is a big bottleneck. So you know what to do, you kind of have figured out where is the value. You're just like the complexity of the code base, getting things implemented in legacy code is just very hard, or oftentimes very hard.
Yeah.
And there are
Yeah.
like this is a big bottleneck, just eyes on the eyes on the code, like hands on the keyboard. Then
Yeah.
with agentic, it kind of some of the shifts into PR review being the bottleneck. You may have 5 PRs, and so do you have enough context to review this? Can you ensure that the overall quality is good, that there are no merge conflicts between multiple things? So this is a maintainer tech lead that becomes a bottleneck. And the thing that you describe now is like, okay, the product manager becomes the bottleneck because the engineering team is so fast. So there is, I mean, productivity wise, it's always what you want to do. You want to just work improving, isolate the bottleneck, remove the bottleneck, and then you can accelerate. And I mean, it points to you can run with less engineers or another product manager to engineers ratio.
Yeah, I feel that there's also another aspect here, that you might not have product managers and engineers as different roles, right? That could be also another scenario, that we kind of, engineers need to become more aware of what product is actually doing, and product actually needs to become more aware of what engineering is doing. So there are these new, I see a lot of trainings already in this area, like product engineering, like what is a product engineer, and then I see some product managers going to these trainings and they see code there and they are happy about it. They learn to code. And I see developers going there and learning about what product managers are doing. So I feel that this could be a different scenario. But as you said, this is also my philosophy, that remove the bottleneck, right? So that's what I meant also with, I try to look at the whole process and figure out how to blend it into the process, and not building some separate AI system that I then pushed on top of them and they need to kind of use it or anything. I don't really think that this is the way how you should go, right? So look at the thing, where's the bottleneck, try to figure out how you can leverage AI to remove the bottleneck. If you can't, look at the next bottleneck, right? And usually, and this is quite interesting, I am not really sure if coding is actually the bottleneck, or is it because the task of the product, the developers, the coding part of the task is often done fairly not quickly, but fairly easily. The more harder part is to figure out the requirements and to actually what does the user want and so on. And maybe it's what I feel at the moment is the hardest part in my job, at least, is to figure out what is the actual bottleneck here. And for which goal is what the bottleneck? Like for spitting out lines of code, yeah, obviously the coding, yeah. I mean that's an easy one, but for spitting out value, I'm not sure. And I feel that we should be, and maybe this is like something, a very good closing as well, is with all these AI, I think we shouldn't focus so much on this productivity thing because this is kind of obvious. We should focus on like how can we actually use that to increase the value of it, and not focus too much on only the productivity side because that will come anyways. Yeah.
Yeah, I mean, I agree very, very broadly with all of this. What we really saw here is how much of the practice is really just the same thing happening in silicon brains instead of human brains. And this is actually a really beautiful insight that like the Kanban stuff, the project management stuff, maybe even product or business literature all stays relevant. It's just like how do we enable the silicon brain, if you like, to carry over more of that. And for me, kind of the high level takeaway is feed it the right context. That's basically like increases the chances more and more that we get output that like good answers, and then having all this kind of guardrails around it that double, triple check the accuracy, kind of get the human in the loop to review, to merge, to evolve the setting. But fundamentally, there are really no hard boundaries that I'm seeing. We discussed the last time, like maybe you don't want to do that in the database. Why not?
Yeah, why not? Yeah.
You just feed it the distributed systems book. Just feed it the Linux manual, like the Linux system book. I forgot the author. Linux programming environment interface. There it is. Then okay, that's like a few megabytes of text, and then it can kind of at least know what it's doing. So it's possible. It's approachable. It kind of needs a lot of like I think iteration, human in the loop to kind of get it there. But once you know what you want to do, telling the LLM what you want to do and what to look for, it's possible. And it's and in the framework like you described, I think there's even not much innovation we need to kind of make that happen.
No, it's not even a data science thing. It's more of an engineering thing. You need to kind of engineer the process around it, engineer the right tool calls and so on. The data science part is also like if you have a better model, this will work better. But you still need to kind of do the engineering around it. A better tool also makes it better in the end. Yeah.
Yeah, and so I think what a lot of us in the companies are kind of informed with doing is just think about the context sources and keep the context sources clean. Think about context management system. Think about context sharing. You showed that you are committed a lot of the stuff in your Git repository. I think that's a good start. Maybe not the end game when it comes to where the stuff should live, right?
No. Like, you can do much more there, but yeah, this is definitely one part is the context thing. I mean, we can get on we could put it even on a higher level that the context can also be harmful, because if you guardrail it too much, you kind of it's like when you work with a human, if you kind of put too much constraints on the creativity of the human, then you will only get the result that your context kind of makes the system or the person being able to produce. And we see that sometimes as well, that when there's a new model with better internal reasoning and so on, the results of our agents don't get better, and that is often because we have put too much context on it and too much restraints. And for a while, it was really hard to have, for example, this idea of test-driven development. We really needed to put it in there in the context to force it to do that. But nowadays, the models are much better, and they kind of figure out when to use test-driven development and when not to do that by themselves. And it's not really necessary to put that in the context anymore, just as one example. And so what I want to say is like, you also need to be careful in terms of like too much context or too hard guardrailing it. But yeah, in the end, it all comes around figuring out the right configuration of that thing for your task, making it also specific, like focusing an agent on a task that you wanted to achieve, and not making like a general purpose doing everything Claude agent thingy, because then it's kind of hard to figure out what are actually like useful constraints and what are not useful constraints. Yeah.
Got it. Maybe to round it off, if our listeners want to get started with this, we saw VS Code, we saw Claude, we saw the agents files, we saw the command files, we saw Taskmaster. Those are like technologies to approach. Is there kind of a starting point, a book, a good website or so that kind of helps you with getting started with all that?
Yeah, and sadly, I can't really name like one address to go to or anything. I like to do it like Boris is doing. Boris is the inventor, the creator of Claude Code from Anthropic, and he has always one tip in his talks about Claude Code, and he always says just try it out, right? Like just open it up and just start by asking it questions. Don't try to do like changes yet, and don't try to do giant sub-agent system. Just figure out and get experience with it. Like if you would hire someone else as a human being, you also try to figure out like what is this person capable of, and you do an interview with him or her. And I would suggest, I'm not like super pro humanizing these things, because these are not humans, right? It's a random generator or like a prediction machine, but of words. But still, though, I like this idea of how to approach this more of an interview, of a getting to know thing than, okay, you want to learn this new IDE and here's the introduction video to it, and look at it. You need to kind of adopt a feeling, a gut feeling, how it will react to certain things and so on. And so my tip would be just take any process. Maybe you start with a refinement and you say, I have this nice transcript here. And then you kind of have the not very well written story. And then you say, well, how could I improve the story based on the transcript? That would be a nice start. And then you will probably be amazed what great results you can already get with that. And all this code generation and having great quality of code and so on, it's so, I wouldn't touch that first. Yeah.
All right. But your Hackers and Wizards startup, is that something that people should reach out for when they want help with this, or is it something different?
I mean, definitely. You can reach out to me. I can help. Once the community is online, you will probably also find some material there. I'm not the one to put me out so much on. You can call me. I can help, but there are others as well, and also starting yourself. I can just help you to help yourself, basically, right? Because the best results, you get the best results when you actually kind of like make the time for yourself to do it. It's very hard for someone else to kind of introduce it to you, or kind of say, okay, well, this is like a nice framework, just use it or something. I think you need to. But I can help you. I can guide you. I can help out when there's like something that is not working and you don't know why and so on. That is where I can where I can come in. I can give creative ideas, what to try next or something like that. Yeah.
Well, I mean, I think that goes far beyond what would be a reasonable ask. What you're offering is kind of support on specifics. I think a lot of our listeners are actually Cloud Code users, so they know kind of what the machine is capable of doing. And I think we also kind of opened the door and then showed the direction of how you kind of can do context management, how you can get started with agents and all of this. So doing this, staying curious, digging further, and I'm sure if you Google agentic coding agents and so on, there's just plenty of material out there.
Yeah, there's a lot out there.
Yeah.
And one last thing
Yeah.
I want to show, it actually implemented the next feature already.
Oh, wonderful.
So I was I let it run in the background, and it is at the validation phase for the next task.
You're sharing a small bar right now, I think.
Oh, really? No. I'm sharing my whole screen.
Okay, then it's a problem on my side.
Yeah, maybe it will record the correct screen. But
Okay,
yeah,
wonderful.
it actually was already pushed the implementation to the database now. Yeah. So as you can see, you can have a meeting while it is implementing your features. I still find it super fascinating. There are so many things that you can do with it. You can be very creative about it. And we are so at the beginning of all of that. Like no one really knows what you can actually achieve with it. And I think there's already, even if we wouldn't improve the LLMs anymore, there's already so much knowledge and capability in here. We have.
Okay, and at this point we had a technical problem, and therefore we had to stop the recording. And unfortunately, when we resumed, our wonderful recording software was not quite able to catch it. So we will leave it at this point. We think we will be back with Benedikt. There's a lot more tangents to explore. We have only really scratched the surface here. So let me here thank Benedikt, like I did also in the original, very much for this fantastic session. Again, it was, we already had two variants of this, which we recorded for different audiences and different purposes. So I'm very much thrilled that we now have a version of that, which is public. And yeah, thank you very much for listening, and have a great rest of your day. Bye-bye.